So I'm very excited here to talk about a project that Ted and Gofran and Viviani and an amazing team, we have been working on this for almost 2 years now, which is about bringing ideas of standardized reporting into economics to say something about publication patterns and eventually something about publication bias in economics. So our starting point is that there has been ever-growing work in the measurement of publication bias. The foundational study for us is the Franco et al. Published in Science in 2014, where we started to think seriously about how to measure the size of the file drawer in social sciences, and furthermore, whether or not if there are differences in terms of what's in the file drawer has more or less null results than what's in the published record. Subsequent work has expanded those ideas into hypotheses, into psychology. Some like modeling has been done in economics to assess publication bias, and also important work from Hoces and Posner in terms of seeing how much heterogeneity there is in terms of pre-analysis plan, and how easy or how hard it is to follow those studies over time. We built on top of that the idea that this growing literature and growing, I don't know if it's in a field that comes from medicine and public health, where there's this commitment to present the paper in a standardized way, where we basically, these journals require authors to say what's the main result, what's the unit, where is it located, and things like that. That spirit we think is very important, but it has been hard to bring it into economics, because in economics there's much more the idea of presenting a story, narrating it in a somewhat free structured way, and what we thought was, okay, why don't we bring this idea of not telling the people how to write the papers, but looking at their papers, looking at their registrations, and say, okay, what's the bare minimum that we would apply, we would interpret as, so like, what's the main hypothesis, what are the results that we can link to those main hypotheses, okay? And this work is also possible because there has been important developments in terms of standardizing the metadata that comes from registrations. Originally in the Digital Data Alliance, DDI, but more recently brought into social sciences from a paper from Cavanaugh et al. In our paper, we focus on at this stage, we focus on 3 specific questions. One, we want to know how many of the hypotheses that we look in the AEA registry are available in the American Economic Association registry, where people deposit registrations for randomized control trials in economics and in social science more broadly. How many hypotheses are available in terms of results 8 to 9 years after the registration was deposited? What fraction of those results are null, and whether or not those results vary, the nullness of these hypotheses vary across types of publication. Okay? So just as a motivation, we're going to use this fantastic tool called the Social Science Prediction Platform, and we ask a group of forecasters, 60-something forecasters, half professors in economics, half graduate students in economics. What do you think we're going to find? What's the average fraction of hypotheses that you think we're going to find once we do this process? We're going to go look and try to get how much is out there. So for a group of studies, we're going to encode the hypothesis and go look. Tell me what's the average fraction of hypotheses that we're going to find. These are the results. Our interpretation of these results is that there's a wide dispersion in terms of what will be found, in what's the average fraction of hypotheses available. But if anything, there's some sort of like heavy pessimism that it's like these are hypotheses. Just to emphasize, we're not talking about only publications. It could be probably a working paper. It could be any type of record. So the idea is that these are hypotheses that were committed to be carried out. The expectation is that we should be finding everything that was carried out, and people, professors, students are saying, nah, you're going to find less than half, way less than half. So with that as a motivation, we're going to estimate this. And to estimate this, we're going to do a lot. We did a lot of work, and we continue to do it, where we basically take these registrations. In the AA registry, you have fields where you register your study, but these fields are used very freely. So people might report their entire analysis in the abstract section. They might report the outcomes in the supplemental documents. So it's not super machine readable, so to say. So we're going to take this free text at the end of the day, which is the registration in the AA registry. We're going to turn it into a rectangular data set where for each study, we're going to have hypotheses. We're going to have the hypothesis that we are encoding. And then for those hypotheses, we're going to go look in the public record, what can we find. So now let me walk you very briefly on what's the process for each stage. On this initial stage, G0 that we call it after reporting guidelines, like the first part, the 0 stage, we start from a metadata structure from Kavanaugh et al., and we add the idea of hypothesis. The idea of hypothesis, there was no metadata for this before, so the way we define a hypothesis is going to be a difference of outcomes for different arms. This is all for causal questions, I should have added. So we categorize 4 types of hypotheses: simple differences, double differences, joint tests, and a regression estimate that's going to be sort of like a catch-all for everything else. If you have like a complicated structural model or something like that, we're going to just annotate the equation and say what's the test that you're running. This is a sample hypothesis. That is a very small, innocent hypothesis that took a lot of work to construct, because first you need to define the interventions, the outcomes, then group the interventions into arms, and then define the contrast between different arms. So these are the students' 2013 test scores in Swahili are not different from students in capitation grants. This is the other arm compared to that of students in the control group. And this one can be written as a simple difference. Okay? Then when this was sort of like the hard job, to build the hypothesis. Then this made it easier for us to then later on, with this hypothesis in mind, we go look into the literature, working papers, published papers, dissertations, everything that we can find online. And only for those hypotheses, we don't look at the entire paper. Only for those hypotheses, we look at what can we find. And we define whether or not the hypothesis is there. We annotate the estimate, and then with the estimate, we compute whether or not it's a null result. And with the estimate and the standard. As I said, for the way we record this is that we have identified the intervention, the arm, and the outcomes, and for each of those, we're going to say whether or not this is available, is the arm available, is the outcome available, and then is the hypothesis available, and also we will identify whether or not this was modified. And if it was modified, was it consistent or not with our judgment of whether or not was it consistent or not with the interpretation of the original hypothesis. Also, we keep track of other information along the lines of how hard was it to find this. The other studies have limited to looking in the abstract or in the results section. We look everywhere. So we also try to annotate where did we find. So in the paper or in the appendix, just to get an idea of that would allow us to build different definitions of availability. We try to go with the most generous definition of availability, even if it's very hard to find, even if it's only in the appendix, we're going to say it's there, but that's going to allow us later on to compare with other definitions. In terms of the process, this was sort of like the backbone of the project, and I could talk endlessly about it. So during coffee, please let's do it. Right now, I'm going to go very briefly, but basically we had 3 excellent coders, research assistants that are pre-docs with a background of master in development economics. We built almost like a free text tool that allow us to record all this information in a pretty unstructured way, such as not in a structured way, but with a lot of modifications, such that we can incorporate different types of outcomes, arms, interventions, and hypotheses. This took a lot of work. The process of the G0 plus the G1 plus all the bajillion revisions that we do afterwards to make sure that this is correct, it's about 11 hours per observation, per study, right? So it is substantial. And until now, we have encoded 230 of these. Our goal is to reach 350, and we're getting close. Our sample, as I said, is the AEA registry. We went as far as in the past as possible to allow these studies to produce any visible output. The AEA was created in 2012 or 2013, but we gave it 2 additional years to allow the AEA registry to mature and for people to learn how to use it in a straightforward way. We also remove main PIs who were duplicate in this sample. So if somebody recorded 2 registrations as a main PI in our sample, we kept the earliest one. Why? Because we're doing another study that is an RCT that we don't want the same PI to be receiving the same message twice. And as I said, extensive quality control. I can talk a lot maybe later, but now I'm going to jump into the outcomes. We're basically going to define 2 outcomes, both at the study level. The first outcome is what's the average fraction? What's the fraction of hypotheses available? For each study, if a study has 10 hypotheses and we find 3 hypotheses, that study has 30% of the hypotheses available. How do we define available? The available is whether or not there's a numerical estimate that exists, that is both the estimate and the standard error. Anywhere in the paper, as I said, the general spirit of the project here was try to be generous with the authors here, regardless of the level of effort, and also allowing for consistent modifications. That means that we can construct a more stringent definition. We can say, we can go with what other literature, with other papers have done and say, like, forget it. We just want it in the paper, easy effort, and forget about the modifications. If it's not the same, we just go back to it. And the fraction of null results, the second outcome, it's basically within the studies that are available, we're going to compute what fraction of those studies are null, defined as the C statistic less than 1.96. Okay? This is going to have some limitations, but I think it's a good approximation. And as I said, we're still collecting data, so this has to be considered as initial results, but we are starting to see some clear patterns that we're at a point where we're pretty comfortable sharing this. So our starting universe here is going to be, our starting sample is going to be 230 studies from 2015 to 2015. And the first I'm going to show you is the fraction of missing papers. How many of these studies don't have a paper after X many years? And we asked this to the forecaster too. So I'm going to show you later on what the forecasters think too. What we find is that there are about 90% of studies, registrations, who don't have any type of report or paper afterwards. This could be studies that were never carried out. This could be studies that were carried out or not written up. We don't know. The important thing to mention is that the Franco study, they also found that about 20% of the studies are never written up. And there's another ongoing project by Taisuke Imai and other co-authors where they also find a similar quantity. So this quantity sort of resonates with that. And this 20%, the 19% is sort of like the quantity that you can tell that until now, at least in economics, it was known to, you could have sort of like some beliefs that this was the size of the file drawer, right? We're not going to say the file drawer problem because we don't know how many nulls are in that box, but at least the size could be argued to be that size, right? So now we come in and say, now let's look at the hypothesis level. A study is a collection of hypotheses. So What happens when we look at do this exercise at the hypothesis level? We learn that there are about 18% of studies that have all the hypotheses. The vast majority have some hypothesis available. Half of all these studies have some hypothesis available. But there are 13% of studies that have no hypothesis available. So that's already some important insight that we think is coming out of our work. But then we can go further. We can say, of those that are some hypotheses available, we can look at, for each study, what's the fraction of available hypotheses per each study. And that's what we see here. So there's a continuum, basically, from studies that almost report everything, from studies to report almost nothing. And if you take the average of fraction of hypotheses available across this entire sample, including the no paper, including the no hypothesis, the average of fraction of hypotheses available is 42%. So on average, 48% of hypotheses are missing per paper. So and we argue that this is the true size of the file drawer. You can say, hey, but what about those no no-paper studies? Those are studies that were never carried out. Okay, never carried out studies. Let's focus only on the studies where we can see at least some document, some paper. The gap shrinks from 58 to 49%, which is the gap shrinks to 85% of the gap. So it's still pretty. It's a large gap. So now I'm going to compare this gap with priors from the SSPP, from the Social Science Prediction Platform, and we ask different questions to gauge these quantities. Of course, we don't ask like what's the average fraction per study, so I cannot show you the distribution. So I'm going to flatten up I'm going to take one average of the available studies within studies that have at least one hypothesis available, and this is what we have here. So again, these are all the studies, and here now we're going to put the fraction of hypotheses available within that category. So within the studies that have at least one hypothesis available, 60% have the average fraction of available hypotheses is 60%. But on average, among the entire group, this average is going to be 42%. Okay? So then we went and asked the forecasters through a sequence of questions, what do you think is going to be the number of papers with no hypothesis, and within this, what's the average fraction of hypothesis available? And this is what we find. We basically, surprisingly, I would say, forecasters widely overestimate the fraction of studies without a paper. Basically, they say that 42% of studies are not going to have, 42% of registrations are not going to have a paper. They also widely overestimate the fraction of studies conditional on being a paper. What's the fraction of studies that are not going to have any hypothesis? They don't overshoot this one. So they're pessimistic here, But surprisingly, on this margin, conditional on the study having at least one hypothesis available, what's the average fraction of available hypotheses? They get very, very close. So that's somewhat surprising. After seeing pessimism, and then boom, right on target. But the overall takeaway is that forecasters predict that on average, this gap, what was the average fraction of hypothesis missing, is going to be 76%. So first takeaway is that we have a large fraction of hypotheses missing, but less than what a group of forecasters would have expected. So now we're going to try to look a little bit more detail what's going on with the missing hypothesis. Let's try to investigate a little bit more. So first of all, for the missing hypothesis, this group, we have a paper. There's no hypothesis, but there is a paper. So I'm just going to take the average all the way up to there. And for those that have some hypotheses available, the average fraction of hypotheses available is 38%. And there, as I said before, there's a group that has all the hypotheses available. So for this one, I'm not going to show you anything. For this one, I'm not going to show you anything, because this one we have all the hypotheses. This one we don't have any information. But for these ones, we have some information. Basically, again, one interpretation could be maybe we misread the hypothesis. Maybe there was no hypothesis where we thought there was one. Okay, so let's see how things play out. So now I'm going to investigate this group of hypotheses, the missing hypotheses that have a paper. And the first thing to point is that of this group, of this entire white box, 30% have both arms and outcomes. So there is an arm, there's an outcome. It's just the hypothesis was not carried out or estimated in the way that it was presented in the registration. So this, in a sense, is sort of like low-hanging fruit, easy to recover, somewhat easy to recover estimates. The vast majority of this group has an arm, but doesn't have the outcome. So the outcome is missing, which again, there suggests that there was an intervention, there was a study carried out for this particular question, but the outcome, it's not reported. And it's important to say it's not reported anywhere in the paper. Okay? So that maybe the outcome was collected, and it's in the replication package, but it's not reported in the paper. A smaller group is going to have the outcomes available, but not the arm. This might suggest that the arm, the intervention, was never carried out. So this might be a little bit harder to find. And the remaining 12%, it's basically our registrations that have no outcome or no arm. So somewhat harder to find a hypothesis. So second takeaway, this hypothesis seems to be somewhat recoverable, an important fraction. And here, this is just a summary. Basically, we don't think it's just a story of studies that were never carried out, because if we focus only on studies that were carried out, 51 of the hypotheses are still available, are available, meaning that 49 are missing. And if we don't, within the missing hypothesis, there are these quantities I already mentioned. And we can get into different definitions of availability, and also different different comparisons of groups, different characteristics that determine availability, but maybe for the questions. Now I'm going to switch into this group, the available hypothesis. Only the hypothesis that we can observe, and we compute, and we extract the estimate, we compute the C statistic, and what's the distribution of the fraction of null results for this group. First, this is what I'm showing you. This is the data, the fraction of null results. There's a large fraction of null results, and of course we're going to compare it with what the forecasters believe. So this is the median in the mean in the data, the standard errors, and this is the mean of the forecaster. So forecasters think that they were not going to find that many null results within this group of available hypotheses, and it's a much larger group. And again, it's very, very important to know what's going on with this white space. We don't have data yet. This is part of a second study that we're carrying out to learn how to recover these estimates. But even within this space, we can explore a little bit how the fraction of results vary across publication outlets. And that's what I'm gonna close with. So if the paper is written but not published, a working paper, it's gonna have 51% of hypotheses available, and within those hypotheses available, 70% are gonna be no. If the paper is published but not in a top 5, it's going to have a similar fraction of hypotheses available. It's going to have a little bit less no. This difference is not going to be statistically significant. But if the paper is published in a top 5, it's going to have substantially less hypotheses available and way less null results. And this difference is, the difference between this and this is statistically significant. So this is not So like hard evidence of publication bias is suggestive because, again, we need to recover what's going on here. It's very important to learn what's going on with the non-reported hypothesis. Franco basically went and asked Franco et al. Went and asked the authors, can you tell me qualitatively what's the result of your study? We're trying to do something like that, but at the hypothesis level. So it's a little bit more tricky. But once we learn about this, we're going to be able to say something a little bit more concretely about publication bias. And just as a conclusion, what I've shown you today is that the size of the file drawer for RCTs in economics is substantially larger than what you would have think so just by looking at availability of studies. That this gap is not explained by not published studies, by not studies that were not carried out. And there are also some systematic patterns that suggest publication bias where no results are less likely to be published and less likely to be published in top 5 journals. And as next steps, basically, we need to write this up. Then we need to, as I said, we're conducting an RCT to understand what kind of interventions can lead to increased reporting of those missing hypotheses. And also, now that we have this very rich human-only coded database, we can start to compare it with the types of encoding that a large language model would do and expand our work. And with that, I'm happy to take questions and chat more about it during coffee too.
We've only got a couple minutes, but we could probably take 1 or 2 questions.
I realized I didn't introduce myself earlier. Don Moore, UC Berkeley. It's fairly common in papers that I've seen where hypotheses determined post hoc to be uninformative or uninteresting often wind up in a supplement. Did you look at both paper and supplementary documents?
Everything we find. Yeah.
Yeah, really great work. I was wondering about the potential role of measurement error. So, in principle, like it's hard to humanly code perfect if the hypothesis was there. You suspect that the difficulty in coding might lead to more in one direction than the other. I'd be really curious if you have 2 independent coders, unaware of each other, blind in that way, and then sort of comparing and then adjudicate the differences. I think that'd be really important to sort of assess the role of that in this.
Yes. Yeah. So the measurement error can definitely be a challenge here, compounded with the very large cost of collecting just one observation. So this idea of that double coding the entire study, it was not possible. We did double code the first 10, and we do a peer quality control. So the other coder checks the other the one that was coded by originally, and there's on top of that for the first 100 they were quality controlled by me basically. I review them, but we could do a subsample of just repeating. Right now, what we're doing is that every so often we do double coding, but we have them talk with each other exactly to learn what are the differences. But I think for a subset we could repeat like a number. Another thing we're doing in the RCT, some of the interventions that we're sending it to the authors and say like, this is what we coded. Do you agree? Do you disagree? So from that we're going to get a measure of how off we were in interpreting the hypothesis and interpreting what's the result associated with the hypothesis.